this video, we're going to talk about the unit circle. First, we're going to refresh our rules on the 30, 60, 90 triangle and the 45, 45, 90 triangle. So the long section of the triangle, which I'll highlight, this is going to be considered your radius of your circle. So since we're talking about unit circle, that means the radius has to equal 1. So that means 2x equals 1. So let's first solve for x. So let's divide everything by 2. That means x equals 1/2. So now if we plug 1.5 in for all that x is, we have, that means this side will be 1/2 because that's our x. Plugging in x 1/2 for the bottom section or the side touching the 30s. So let's highlight. Let's make, this is our 1/2. So that's the side. Now let's deal with this bottom. Let's do that one in below. So that'd be 1/2 times √3. So that's just √3 over 2. Oops, wrong color there. Okay, so that covers the side touching the 30, covered the side touching the 60. Only thing we have left to do is we know that the pink side is 1, so we are done solving the 30, 60, 90 triangle. So the ratios we would have will be 1/2. This is the side touching the 60. √3 over 2 is going to be the side touching the 30 degrees, and 1 is the hypotenuse. And we're done with the 30, 60, 90. Now, for 45, 45, 90, we have x √2. That's also going to be equal to 1. So let's how this is going to be your radius. So we'll set x √2 equal to 1. So we'll say x √2 equals 1. We'll divide everything by √2. Now the problem is we can't have a square root in the denominator, so we have to rationalize it. So we have to multiply the top and bottom by √2 over 2, which gives me 1 times √2 is going to be √2, and √2 times √2 is going to be √4, which this breaks down to √2 over 2. That's my x. So since we have two sides that are the same, let's do that in this lime green. That means both of these sides are √2 over 2. And this is also √2 over 2. So our sides will be √2 over 2, √2 over 2, then 1. And we're done solving our triangles. In this section of the video, we're going to convert our degrees to radians. You can see the formula for degrees into radians in a previous video. We're just going to use technology to do that in this video. I'll also add the link to this file so that way you can use it for your conversions. So the first degree will be 0 degrees, and that's going to convert to 0 pi. 15 is not important. The next one will be 30 degrees, which will convert to 1/6 pi or pi over 6. Then we have our 45-degree angle, which converts to 1/4 pi or pi over 4. Then we have our 60-degree angle, which converts to 1/3 pi or pi over 3. We have our 90-degree angle, which converts to 1/2 pi or pi over 2. we have our 120-degree angle, which converts to 2/3 pi, or 2 pi over 3. We have our 135-degree angle, which converts to 3/4 pi, or 3 pi over 4. We have our 150-degree angle, which converts to 5/6 pi, or 5 pi over 6. We have our 180-degree angle, which converts to pi. We have our 210-degree angle, which converts to 6 pi, or 7 pi over 6. We have our 225-degree angle, which converts to 5/4 pi, or 5 pi over 4. Our 240-degree angle, which converts to 4/3 pi, or 4 pi over 3. Our 270-degree angle, which converts to 3/2 pi, or 3 pi over 2. Our 300-degree angle, which converts to 5/3 pi, or 5 pi over 3. Our 315-degree angle, which converts to 7/4 pi, or 7 pi over 4. Our 330-degree angle, which converts to 11/6 pi, or 11 pi over 6. And then we're back to the beginning, where we have 0 degrees, or that could be 360 degrees. So we have full 360-degree revolution about this circle. So the other thing I want to point out, and I'll try to write on this, this is also 0 degrees, or 0 pi. So the pattern that we say is to get each of these, memorize these circles, we're just adding 30 all the way around. So everything I'm highlighting in black, we're just adding 30. So 0 plus 30 will be 30, 30 plus 30 will be 60, 60 plus 30 will be 90, 90 plus 30 will be 120, 120 plus 30 will be 150, and then 150 plus 30 would be 180, 180 plus 30 would be 210, 210 plus 30 would be 240, 240 plus 30 would be 270, 270 plus 30 would be 300, 300 plus 30 would be 330, and then 330 plus 30 would be 360. And we filled in almost 2/3 of the circle. What's left is the 45-degree angle. So the ones that I didn't highlight, we can just add 0 plus 45 would be 45. 45 plus 45 would be 90. So I'll circle these. So this is just adding 45. 45 plus 90 plus 45 would be 135. 135 plus 45 would be 180. 180 plus 45 would be 225. 225 plus 45 would be 270. 270 plus 45 would be 315. And then 315 plus 45 will bring it back to 360. So everything I just circled is just by adding that 45-degree pattern. Everything, all the lines I highlighted and drew over the lines, that's just by adding 30. So that should help you memorize which degrees are most important for the unit circle. In this section of the video, we're going to learn about the x and y values of the unit circle. In other words, the coordinates and what the cosine and the sine values correspond to. So first, I'm going to write above what cosine corresponds to. Cosine corresponds to the x coordinate, and sine corresponds to the y coordinate. So when we think about the unit circle, when we think about the coordinate planes. So we have our first quadrant, our second quadrant, our third quadrant, and our fourth quadrant. Okay, so let's start. If we look at where we start, we're at the point 1, 0. And that's where cosine is, where the 0 is the base, or we're 360. So if we take a look, cosine is your x. So 1 is, cosine of 0 is 1, sine of 0 is 0. So that's your x and y coordinates. Now let's move it around. Now if I drop a perpendicular to the x-axis, we have a 30-degree angle, which corresponds to a 30, 60, 90 triangle. So the x coordinate will be square root of 3 over 2. The y coordinate will be 1/2. So in other words, the sine of 30 will be 1/2, and the cosine of 30 will be square root of 3 over 2. Continue to work our way around. We're at a 45-degree angle, and that corresponds to the 45, 45, 90 triangle. So the sine and cosine of square root of 45 will be square root of 2 over 2. Making our way to the 60-degree angle. The x coordinate would be 1/2. The y coordinate would be square root of 3 over 2. So the cosine of 60 will be 1/2. The sine of 60 will be root 3 over 2. Making our way to 90. Take note we're at the point 0, 1. So the cosine of 90 will be 0. The sine of 90 will be 1. Making our way to 120. And take note that that's almost exactly like the 60-degree angle, but the only difference would be the x coordinate's negative, the y coordinate's positive. So the cosine of 120 would be negative 1/2, and the sine of 120 would be square root of 3 over 2. Making our way to 135. Again, the x coordinate's negative, the y coordinate's positive. So the cosine of 135 will be negative root 2 over 2, and the sine of 135 will be positive root 2 over 2. Making our way to the 150-degree angle. Again, that matches with the 30-degree angle. So the only difference is the x is negative, the y is positive. So cosine of 150 would be negative root 2 over 2, and sine of 150 would be positive 1/2. Let's make our way to pi, or 180. So again, the cosine of 180 would be negative 1. The sine of 180 would be 0. Let's make our way around to 7 pi over 6, or 210. In quadrant 3, both the x and y are negative, and 210 corresponds to 30. So the cosine of 210 will be negative root 3 over 2. The sine of 210 will be negative 1/2. Let's keep making our way around. So for the 225-degree angle, that corresponds to the 45-degree angle, but again, both the x and the y are negative. So the cosine of 225 will be negative root 2 over 2, and the sine of 225 will be negative root 2 over 2. Continue making our way around. So the 240 corresponds to 60. The only difference would be both the x and y are negative. So cosine of 240 would be negative 1/2, and the sine of 240 would be negative √3/2. For 270, we're at the 0.01. So cosine of 270 would be 0, and the sine of 270 would be negative 1. For 300, that corresponds to 60. The only difference is the x is positive, the y is negative. So the cosine of 300 will be positive 1/2, and the sine of 300 will be negative √3/2. 315 corresponds to 45. The difference would be x is positive, sine is negative. So cosine of 315 would be √2/2, and sine of 315 would be negative √2/2. For 330, that corresponds to 30. Difference being x is positive, y is negative. So the cosine of 330 would be √3/2, and the sine of 330 would be negative 1/2. And now we're making our way back to 360 or 2 pi. So 0 and 360 are both the same. Cosine of 0 and 360 are both 1, and the sine of 0 and 360 are 0. Now let's show them all. And this is a representation of every coordinate in the unit circle. I'll add this file to, I'll add a link to this file in the comments. Hopefully this helps you understand the unit circle.